These are the solutions to your recent linear functions and Galleria graphs tests. So without further ado, let's get into it. Okay, the first question was a pretty much bog standard algebraic solve. So the first thing you needed to do was expand the brackets out, collect up like terms. So we'll go 3x take 6, take x, take 5. That was where the big mistake was there. A lot of you guys just wrote out plus 5 equals x plus 2. Now we're just going to subtract the x's here. So that's 2x take 11 equals x plus 2. Now what we'll do is add 11 to this side and at the same time subtract x from this side. So x will equal 13. This one here wasn't done fantastically, and many of you did the move that I would make first of all, which is multiply everything by 3. But what you forgot is you just multiplied this side or this term by 3 here and forgot to multiply this one by 3. So this is how I would do this one. So I'm going to write this as x because I'm multiplying that by 3 to get rid of the divide 3. Take 9 becomes take 27 equals 3x on 2. Now I'm going to multiply everything by 2. So that's going to give me 2x take 54 equals 3x on this side. Then I'm going to subtract 2x over here, which will give me x equals negative 54. Okay, the simultaneous equations question. So what I'm going to do is use the method of substitution. I'm going to put y into here. So 1, 2, I'm going to sub 1 into 2. Okay, so that means I've got x take negative 2x plus 3 equals 2 after the substitution. X plus 3x take 3 equals 2. 4x equals 5 and x equals 5 on 4. Now I'm going to sub x equals 5 on 4 into one of these ones, and it's going to be 2 that I'm going to put it into. So I've got 5 on 4, take y equals 2, negative y equals 2, take away 5 on 4, negative y equals 10 on, no, I won't do that, equals 8 on 4, take away 5 on 4, negative y equals negative 3 on 4, or y equals 3 on 4. So there's our two solutions. No need to write them as an ordered pair because this is not on the Cartesian plane, but it can't hurt, okay, to write it as an ordered pair, but all you need to do is say x is equal to that and y is equal to that. Many of you found x and then forgot completely to find y, so common mistake that. Okay, this one here was done very poorly indeed. Okay, so what we wanted to do was solve for x, and there's just a bit of a condition on x here that x has to be less than 0. So when you're doing this, really, if we're solving for x, we're going to get one instance of x. So what I'm going to do is swing all of the x's onto the left-hand side. So I'm going to rewrite this as ax squared take bx squared equals c. All right, now a common technique here to reduce these two x's down to 1 is to factorize it. So we're going to go x squared a take b equals c. All right, so now what I can do is divide this by a take b and divide this by a take b, which leaves me with x squared equals c over a take b. That was worth 1 mark to this point here. Okay, so now to solve for x, I need to square root both sides. X is the plus or minus square root of c over a take b. That was where the second mark came from, or your second mark out of 3. All right, now finally, because x has to be less than 0, so x less than 0, therefore what we're going to do is we're going to ignore the positive and only take the negative root. So x equals negative c over a take b, and we're done with that one. That was the third mark, is taking the negative. Okay, the rectangle or length of a rectangle, so here's my rectangle, is 12 centimeters greater than twice its width. Okay, so if its width is x, the length is going to be 12 centimeters greater than twice its width, so 2x plus 12. Right, so to write out our equation, the perimeter is 48 equals x plus 2x plus 12 plus 2x plus 12. All right, which is in total 6x plus 24 equals 48. We're going to subtract 24 from both sides, leaving us with 24 and 6x. X is equal to, what is it? X is equal to 4. Okay, and then what we're going to do is note that this asks for the length and the width. Okay, so the width is equal to 4 centimeters. Length will be equal to 2 lots of 4, which is 8. 8 plus 12 is 20 centimeters. And we're also noting that that's 24. 24 doubled is 48, which is the perimeter. So it's looking good. Okay, consider a straight line that goes through these points here. We want to show that the equation of that line is this. Now remember, you're not allowed to just sub points in. Okay, you can't just do that to show that. Okay, so what we've got to kind of do is instead pretend like they didn't give us this. We don't know that. Okay, and we want to basically find the equation. So what we do is we find the equation with those 2 points. Now it's really important to know why they gave us that, and that's going to be used somewhere in a future question. So often show that questions are because even if you make a mistake here, you can still enter into some of the latter questions. Okay, so we're going to pretend like they didn't give us that equation there. We're going to use the points to show that this is the equation. So I'm going to get the gradient by doing negative 3 take 11 over 4 take a half. That's negative 7 over 8 on 2, take away a half, which is negative 7 over 7 on 2, which is the same as negative 7 divided by 7 on 2, which is the same as negative 7 times 2 over 7, which is the same as negative 14 over 7. What's gone wrong here? Equals negative 2. There's my mistake. Okay, so I can't read my own handwriting. That was not a 4. That was supposed to be an 11. Okay, so negative 3 take 11 is negative 14 over 7 on 2, which is negative 14 divided by 7 on 2, which is the same as negative 14 times 2 over 7, cancels 2 equals negative 4, which again is a great example. Even as I'm working this, I can't read my own writing and I make a mistake there. But it's great that I show that question, you know whether you're right or wrong. I was getting negative 2 there, needed to be negative 4, so that's why that's a really handy thing to have there. Okay, so I've now got my gradient, which means my equation would look like this. Y equals negative 4x plus c. Let's sub one of these points in. Of course, it's going to be this one. Negative 3 equals negative 4 times 4 plus c. That's negative 16 plus c equals negative 3. I'm going to add 16 to both sides. C is equal to 13. Therefore, the equation is negative 4x plus 13. Okay, coordinate of the x-intercept. So note that we're after the coordinate. So this needs to be written as an ordered pair. Right, the x-intercept occurs when y is equal to 0. Negative 13 equals negative 4x. X equals 13 on 4. 13 on 4, 0. So many of you forgot to write that as a coordinate. and as a consequence got no marks for that. All right, state the gradient of the line that runs perpendicular to this line here. So for 1 mark, really, we can use just the rule, which is the negative inverse or negative reciprocal of that. So it's going to be m equals, or m2 equals 1/4. But again, just for a little bit of explaining, remember perpendicular lines have gradients that multiply together to equal -1. So -4, which was the original, multiplied by negative, or positive rather, does equal -1 in this instance. So that must be our answer. The vertical line goes through 4, -3. What's the equation of that line? So again, it goes through this point here when x is 4, y is -3 down there, and the line is vertical. That is, x is always 4. The line perpendicular to this line here goes through this coordinate, and what we wanted to do was state the equation of the line. Okay, so we know that it was going to look like this: y equals quarter x plus c. That is, I don't know what the y-intercept is. Now what we're going to do is put this coordinate point in. So that is 3 on 2 quarter plus c. Now what we're going to do is do 3 over 2, take away a quarter, equals c. C equals 6 over 4, take away 1 over 4, c equals 5 over 4. So therefore our equation is y equals quarter x plus 5 over 4. But because we want it in this form here and we want these to be integers, what I'm going to do is multiply all of these terms by 4. So I'm left with 4y equals x plus 5. All right, and then I'm going to swing the x over to the left-hand side. So I've got -x plus 4y equals 5. Integer, 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 and the x's and y's in the right spot. You could put it as 4y take x equals 5. Okay, it just has to be the x and y term on the left and the constant on the right, and the a, b, and c value had to be integers. Okay, so we've got 2 points on a line that appear on the graph below, and what we needed to do was state the equation for the angle theta the line makes with the positive direction of the x-axis. Right, so I need this angle here. Okay, so this is theta. So to do that, I need to be aware of that gradient is the tan of theta. All right, so what I need to do is work out the gradient here. So m equals -5 take 3 over 4 take -2, which is -8 on 6 or -4 on 3. All right, so what I'm going to do now is, using that gradient, I'm going to work out theta. Okay, but there's a few little issues here with using this gradient. So I'm just going to write some discussion points here. So if I sub it straight in, all right, so I'm going to go -4 on 3 equals the tan of theta. That means that to get theta, I do tan inverse of both sides of -4 on 3. But you'll recall that what this will do is actually give us this angle here, and it will tell us to go in the negative direction. Okay, so to actually get theta, what I need to do is say that theta is actually 180 plus the tan inverse of -4 on 3. The other method, which is often taught, is to note that you just take the positive gradient, so 4 on 3, and you remove it from there. That's the other option there. So my class, when I saw that done right, that was the method you use, and Ms. Cowan obviously taught that way there, and that's the method that her class generally used. But in general, you guys struggle with that question. Okay, so we had to sketch this graph here. So this was, note the form before you get started. It's a parabola, and the parabola is going 3 units to the left, so -3, and up 1 unit. So that's the turning point. We're going to mark that as such, -3, 1. Okay, because it's an inverted parabola, it's going to go like that. So I just need to get the y-intercept. Y-intercept occurs when x is 0. So that's going to be -9 plus 1 is -8. So noting the scale 1, 2, 3, 4, 5, 6, 7, 8. It's going to be pretty low on mine. So here is -8 down here. All right, so it's got to go up and around and through there. So all I need now is the x-intercepts, which occur when y is equal to 0, -x plus 3 squared plus 1. I'm going to subtract 1 from both sides. Now I'm going to negate both sides. 1 equals x plus 3 all squared. Now I'm going to square root both sides. That gives me plus or minus 1 equals x plus 3. Then x is going to be equal to -2, or x is going to equal -4. So here's -3, -2, -1. Okay, so there is another point there, and roughly, to make sure we're kind of symmetrical, I'm going to have a point there. Right, so I'm going to do my best to draw this, although this is my excuse here, is that I'm using a stylus, and I'm not actually drawing on a screen here, I'm drawing on a pad next to my computer. So it is a little bit tricky to do this, but I'm going to do my best. Here we go. Oof. Okay, so again, you're going to have to excuse that, and you're going to have to make sure that those get smoothed out on your working out. But I just can't do that properly on these pads here. Okay, obviously yours would have to go through these x-axis intercepts, and these, of course, all axis intercepts need to be labelled as such. So this is x is 0, y is -8. This is -1, 0, and this is -4, 0. Okay, so this one here is just your bog standard sort of x-intercept, y-intercept linear. So I'm going to let x equals 0 to find y. So 2y equals 6, y equals 3. Okay, so the y-intercept is 3, and we're going to label that as 0, 3. X-intercept occurs when y is equal to 0, so that's going to be 3x equals 6, x is equal to 2. Okay, so 2 is there, 2, 0. Again, you'd need to pick up your ruler and draw this, okay, but I can't use a ruler on these pads, so that's my best effort. Okay, this is the hyperbola off last year's methods, 3-4 methods exam. So I put this on because I wanted to really show you that the graphing on the 3-4 methods exam isn't that tough. Yeah, and most of you did really well on this one. So we're noting that the asymptote here, or the vertical asymptote, occurs at 1. Okay, so that's x equals 1, and the horizontal is at y equals 2. Okay, so again, I'm hoping that you would rule those up. Right, so now what we need to do is just find out what the x-intercepts and y-intercepts are. So it's a normal or a positive hyperbola, so it's going to go there and there. So we're going to get intercepts somewhere around here, either in going through here or out here. Okay, so let's just see where they are. So we're going to get let's get the x-intercept first. So x-intercept occurs when y is 0. So x equals -1/2. So there it is there. And I'm just running out of room here, but -1/2, 0 is my x-intercept. Now the y-intercept. So the y-intercept occurs when x is equal to 0. So y equals 2 plus 3 over negative 1. Y equals 2 plus negative 3. Y equals negative 1. That doesn't seem right. Just going to pause that. Okay, so just spotted my mistake there. Pretty rookie error there. I plotted the point negative a half comma 0 as positive a half. Okay, and again, I knew that this was going to be wrong because I'm coming up with a y-intercept of negative 1 over here, and what was really clear is that if I put it at negative 1, which is there, there's no way I can draw this hyperbola. So again, it's a pretty good example of how even if you get values or you plot them, make sure that the graph kind of makes sense. So I'm just going to change that to a positive sign there and just put another one over here. That's negative a half comma 0. And let's put the negative 1 in. So there would be 1. So I'm just going to go roughly the right distance there, negative 1. Right, again, you're going to have to excuse my graph here. This is only going to give you the general idea of what it should look like. There's one side of the hyperbola, and what I'm going to do is just note that these points here will be mirrored across the line there, and I'm going to draw another one and just make sure it looks balanced on both sides, which that would. Okay, so again, yours would have to have ruled asymptotes. I need to label this x or y axis intercept rather. And it would need to certainly have all the coordinates there. And see how this line here kind of moves away from the asymptote again? Well, it can't deviate away from the asymptote. It must head towards it, but it certainly not touch it. So again, just make sure that you're very clear with your graphing there. And again, I'm going to run the excuse that I'm on a stylus here, and so it's very difficult to draw these things. Right, this one was certainly a tough graph, and many of you struggled with this. Okay, so I did one similar to this in the notes, and what I recommended you do with these ones here is actually pull out the negative from here, x take 3 plus 1. And what that means is my square root function is going to move 3 to the right, 1 up. So here's 3, and here's 1. Okay, so that's where it starts. All right, and then I need to know which way the flick is. Is it like that or like that? Okay, so without a negative sign out the front here, I know it's either going to flick that way or it's going to flick that way. Okay, so basically to work it out, what I do is I'm just going to put in 4 here first of all. 4 take away 3 is 1. 1 negated is negative 1. Can't square root it. It must flick this way. So all I need to know is work out what the y-intercept is, okay, and we weren't even really worried about scale. So that's the way it would flick off to the left there. I'm just going to try that again, Control Z. So something like that. So to work out the y-intercept, I'm going to let x equal 0. So y equals the square root of 3 plus 1, and there is our y-intercept, okay? So when x is 0, y is root 3 plus 1. And that was all you needed. Endpoints are required as well. So 3, 1 for the endpoint. Okay, this one here, state the equation of this graph here in terms of a and b. So you just need to note that the standard form of a truncus will look as follows. Y equals a, x take h squared plus k. Okay, so what we are aware of here is that it's a truncus. Okay, it's upright. So this a value here is going to be positive. Okay, it says an equation, so I don't really know what it is. So whether it's got a dilation factor or not, I don't know. But I'm just going to state that it could be 1, could be 2, it could be 50, it could be 100. Okay, so this A value here could be anything. Okay, and a lot of you assume, so this would be an incorrect assumption, is it's x plus A all squared plus B, because what you think is that this A value here is negative. Okay, and if it's a negative A value, you negate this value here and put a plus. Okay, that's a common mistake on that one. This question here is really an old trick. Okay, so what you need to do is just note that this A value here could be anything. Okay, and it just happens to be on the negative side. It could be on the positive side, but really it could be anything. So the trick is here, girls, is just to write it as it would be. So x take A all squared plus B. Okay, and that was all you needed to do for that one. Okay, so we've got a circle here. So state the value of A if the radius of the circle is 5. So this is the equation. Obviously, its center point is the origin. So if the radius of the circle is 5, my equation is going to be x plus y equals 25, noting that the standard form will be x squared plus y squared equals r squared, the radius squared. All right, so what is the bottom, the equation of the bottom half of the circle? So there's a couple of ways to do this, is simply by recognition, but we want the equation of just this part here. Okay, so what you can do is note that if we do a transposition of this equals 25 take away x squared, we root both sides, y is equal to plus or minus 25 take away x squared, and because we want the bottom half, so we're going to say bottom half, so y equals negative 25 take away x squared. Okay, so that's how we take the bottom half, but you could have just written that out by recognition. That was only a 1-mark question, so you didn't need to go through all of those. All right, this determined the equation here is a cubic. Y equals a x take h cubed plus k. So that's the standard form of an inflected cubic. So what we are going to do is note that the inflection point happens there. So it's a x plus 1 all cubed, take away 2. We've got a dilation factor here, and we're obviously going to be flipped because our standard cubic is going to look like that. So it's going to be, or it needs to come out negative. So what I'm going to do is put the y-intercept in and see what happens. Y equals negative 5, a 1 cubed take 2, negative 5 equals a take 2, a equals negative 3. So that's a good sign that that came out negative. Therefore, my equation is y equals negative 3, x plus 1 all cubed take 2. Okay, a pretty tricky problem here. So this was a justify that there will be infinitely many solutions, which means that basically this line here and this line here will be the same. So what we're going to note is that the first equation is negative 6x plus 5. And what I'm going to do is have a look at this one, which is 12x plus 2y equals 10. 2y equals negative 12x plus 10. Divide by 2, divide all of that by 2, y equals negative 6x plus 5. And so what we're going to note here is if this is equation 1 and this is equation 2, m1 equals m2, that is negative 6 is the same as negative 6. And we've also got the same y-intercept, so c1 equals c2, or 5 equals 5. Okay, so that's enough to justify that there'll be infinitely many intersections. So this one says, if there is infinitely many, state a possible solution. So what's one solution to them? And most of you guys who picked up where this question was going just noted that the y-intercept of this one is 0, 5, which would be the y-intercept of this one. So that was one solution. Some of you subbed in 1 into this, which came up with negative 1, ... There's infinitely many solutions. So the equations in B have infinitely many. We can't list them all. So what we're going to do is use a parameter to describe all of the solutions. So I'm going to say let x equal this parameter lambda. Again, we just use lambda because that's what the Cambridge textbook seems to do. And I just want to be consistent with, what you've worked with in the past. So x is equal to lambda, in which case I'm going to sub x equals lambda into one of these equations here. I'm going to sub it into y equals negative 6x plus 5. That basically means if x is lambda, y is equal to negative 6 lambda plus 5. And there really is my solutions. You didn't have to write them as an ordered pair, but 6 lambda plus 5 is the infinitely many solutions where, and this is good practice, lambda is an element. Ooh, that's the worst element symbol I've ever drawn, element of the set of all real numbers. So you can pop in any real number for lambda there and it'll generate a solution for you, whatever you want. All right, this one was indeed a tricky problem. So what we needed to do was show that this was an isosceles triangle. So to do that, we're just going to quickly sketch it up here. So on a Cartesian plane, -2 and 3, 2 and 7 down here, -1. So that was going to be our triangle, something like that. Okay, so what we're going to note here is that the properties of an isosceles are that they have two side lengths of the same, one different. So we need to go about kind of proving that, okay, proving that that's the case. So what I'm going to do is basically work out the distance. So this is A, this is B, and this is the C. I'm going to work out the distance between AC, the distance between AB, and the distance between BC. All right, so we're going to use the distance formula. Distance is the square root of, and I'm just going to work out the distance between these 2 points here. So it's going to be 4 squared plus 3 squared equals 16 plus 9 is 25. The distance is 5. So distance between AB is 5. So let's just note that down. Then I'm going to do the distance between, let's do what, B and C. So that's going to be -1 take away 2, which is a distance of -3. So because it's going to be squared anyway, I'm just going to write 3 and square it. -3 squared is also the same thing. 7 and 3, the distance is 4 squared. So that is 16 plus 4, that's root 25, and that is 5. So the distance between BC is 5. All right, now let's do distance equals the square root of, and we're going to do the distance between these two here, and this one has to be the one that comes up different to show that it's an isosceles. So -1 and -2 is 1 squared, 7 and 0 is 7. So that's root 50. So dist between AC is root 50. You could simplify that, but it was good enough to show that really now it is an isosceles. So you just needed to say a final statement. So AB equals BC, which is not equal to AC, therefore it is isosceles. So now that we've established that, what we had to do was find the height of that triangle. So let's just do what it was. So we've got 5, 5, and root 50. So what we needed is this here, the height. Okay, so what we were going to do is just take out the right angle portion, which is 5, and note that this is root 50 on 2, and this is what we're after, the height here. So we're going to use Pythagoras' theorem. C squared equals A squared plus B squared. 5 squared equals root 50 on 2 all squared plus B squared. So B squared equals 5 squared take away root 50 on 2 all squared. B squared equals 25 take away 50 on 4, 25 take away 25 on 2, which is 50 on 2 take away 25 on 2 is 25 on 2. Okay, and then, so that's B squared, where they then square root both sides, which is B equals 5 over root 2, or if you want to rationalize, which you don't have to do, B 5 root 2 over 2. So that's the height, and that is that many units. Okay, so the final question, which it was rare to see anyone getting anywhere with this one in my class. So got this building here separated by a vertical window with this equation here summarizing the hybrid function. So we're just noting that this part of the roof, this one here, must relate to this part of the hybrid function, and this one obviously is this one because they've got the positive and the negative gradient. And so what we're after here is this b value here. Okay, that is, when does one hybrid function stop and the other one start? When's the cutover between these two? All right, so a few of you tried a couple of methods, but the winning method was the one where what you did was noted that this one here, or this b value here, would be the intersection between this line and this line. So what you guys did was you sent this line up 1 unit. You changed the y-intercept. Instead of being, in this case, plus 5, you changed it to plus 6. Okay, so what you would have done then is looked at when w on 2 plus 3 is the same as negative w on 6. Instead of writing plus 5, we shift this up 1 unit to be plus 6. And then you just solve it simultaneously to get the value of w. Okay, now note that that's going to be the width value here, okay, at that particular height, whatever it is, okay, and then what we're going to do is just say that that is going to be the b value. So let's just do the arithmetic on this. We've got w on 2 equals negative w on 6 plus 3. Now, how am I going to do this? Let's add w, so w over 2 plus w over 6 equals positive 3. I'm going to do 3w on 6 plus w on 6 equals 3. That's 4w equals 18. W equals 18 on 4 equals 9 on 2. Therefore, the b value must be 9 on 2. Okay, so once we got the w, the width intersection point there, we just know that that must have been the point of b. Okay, and that was how you do the final question there. So certainly a tough one there to finish up on.